Hi, welcome back to Get Started with IBM Streams. In this video, I'll be walking you through how to complete the first lab, developing a simple application. If you didn't run across any problems while doing the lab yourself, feel free to skip this video. Okay, so to start, let's open Stream Studio. I'll just stick with the default workspace location. Now Studio is going to set things up for us, so let's just wait a little. Okay, so now let's first create an SPL project. We can do so by clicking File, New, and Project. Now let's select SPL Application Project. And that should be located under IBM Stream Studio, right here. Or alternatively, you can just filter it, SPL App. And you can click Next or just hit Enter. Now let's name our project My Project. And let's name our namespace my.name.space. And let's name our main composite My Main Composite. And hit Next. By default, the SPL application project includes all the available toolkits, but we really only need one, which we'll manually add later. So let's deselect them all for now, and then let's click Finish to finish creating our project. Okay, so now let's take a closer look at the Project Explorer section. The main composite is located under the namespace, and each composite can contain multiple builds. In this case, there's only one build. You also have a resources folder that contains 2 XML files, and these XML files contain information about the current application as well as the toolkits it's using. There's also a data directory, which is considered the root when you're specifying relative file paths. Lastly, there's an output folder where your application bundle will be compiled and stored. Okay, so the first thing we're going to do with this project is create a schema, which is also known as the stream's type. Every stream has a schema. You can either define the schema for every stream you create, or the better approach is to create one schema and just refer to this schema in all of your streams. This eliminates code duplication and improves overall consistency and maintainability. So let's create a schema by right-clicking anywhere on the canvas. Make sure you're not actually right-clicking inside the composite. So right-click anywhere on the canvas and select Edit. Then in the Type section, click on Add New Type, and let's call it Location Type, and click Enter to create it. Now we can add a bunch of attributes to the schema. You should have ran across a table that contained all the attributes you need to fill in here when you did the lab yourself, so I'll just quickly fill this out. One tip is that you can press Tab to go to the next column and row to make keying these in a lot faster. Okay, so now that the attributes have been defined, let's save with Ctrl S. The project will automatically be rebuilt to include the schema we just created. Okay, so now that we've created a schema, let's add some operators to our application. To add these, let's type fill into the palette's filter to narrow down the available operators. And now let's drag file sync into the main composite. And let's also drag file source and filter. Now let's organize these a little. Now you can probably guess what we're going to do next. Let's connect our operators by dragging from an output port of one operator to the input port of another, which are indicated by these squares. You'll have to click on the second square to actually create the stream. And let's do the same for filter to file sync. These arrows represent streams, the data that flows between operators. Solid lines represent streams that already have a type, and dotted lines represent ones that don't. Let's save once again. and this will automatically recompile our app. Now, as you can see, our application is complaining that our streams don't have stream types. So let's add types to them by clearing our filter and looking for the schema we created earlier, which should be located under schemas here. Now let's drag and drop our location type onto our streams. They'll turn green to indicate when to drop. Finally, let's click on the layout button on the toolbar here to organize our view. Next, for organizational purposes, let's give our streams and operators more descriptive names. To do so, let's click on the first stream right here. And let's go to the general section of its properties, and there you'll find a rename button right here to the right. Let's rename it to observations. Now let's rename our first operator, and we can do so by clicking on it and going to the general section of its properties. Clicking on rename, and let's give it an empty value. An operator with an empty value for a name automatically takes on the name of its output stream. In this case, it's observations. This makes sense if you think about it, because it's the operator that's actually generating the observation data. So I'm just going to quickly rename the next operator in stream 2. Let's rename this to filtered. And let's rename this operator to the same thing as our first operator. Let's empty out its value. And it should automatically take on the name of its output stream, which was filtered. Now the last thing we need to do is fill in the parameter values for our operators. Most operators require you to fill in at least one parameter for them to function, and in our case, all three of our operators require this. The first operator is a file source. It reads data from a file that we specify, so let's go to the param section of its properties, and let's add a few parameters. So let's add file, and let's add format, and click OK. Now let's fill in a value for our file parameter. Remember that the value has to be enclosed in quotation marks. So the file we want to read from is located in home/streams/admin/data/all.cars. Now let's click enter. This is an existing file that came from the lab package that we installed. Now let's fill in a value for our format. This value should be CSV. Let's click enter. And let's save. Now let's fill in the parameters for the file sync. This operator takes incoming data and outputs it to a file. In the parameters section of its properties, let's give its file parameter a value of filtered.cars. Remember to enclose it inside quotation marks. Now if you notice, this file path doesn't start with a /, which means that it's a relative file path. This means that when it's created, it's going to be created inside the data directory of our project. This is because the data directory is considered the root when specifying relative file paths. Now let's add two more parameters to this. Let's add format and quote strings. And the values for these should be CSV and false. Okay, so now the last operator we need to edit is our filter. So let's go into its parameters and let's add a parameter. The only one we can add is filter, so let's add that one. And the value for this should be ID in brackets C101 and C133. Make sure you get this right because the format really matters here. The filter's job in this case is to find all incoming tuples with IDs equaling C101 or C133 and outputting this into another stream which will get read by our file sync. Our file sync will then write this to our filter.cars file. So let's save this to recompile our application. And as you can see, all the errors should be gone, which means we should now have a fully runnable application. To launch this, right-click on our main composite, hover over Launch, and select the second option, Launch Active Build Config to Running Instance. And click Launch. And click Yes. Now let's monitor our application by heading over to the Streams Explorer located next to the Project Explorer. And let's expand our instances. Now let's right-click on the only one we have and select Show Instance Graph. If all went well, our graph should be green, indicating that it's healthy and that there's data flowing through the application. If it's red, the application has either run out of data to stream or there could be a mistake in one of your operator's parameters. Let's verify that the data is being read, filtered, and output to a file by going back to our Project Explorer. Let's right-click on our data and refresh it. And as you can see, a filter.cars file has been created. Now let's double-click on it. As you can see, the tuples with ID equaling C101 and C133 were indeed written to our file that we specified. That's about it for this lab. Hopefully it was easy to follow along, and hopefully everything worked for you. You have successfully built your first Streams application. I'll be seeing you in the next video where I'll be introducing Lab 2.